Welcome to the problem section for the reference angle. We're going to do quite a number of problems. However, each one of them is relatively short. So let's get started. First one, draw in standard position and name the reference angle for theta equals 210 degrees, theta equals 150 degrees, and so on. So let's go over to Word and do that. I'm sorry, let's go over to Paint and do that. Let's choose the color blue for the angle, so 210 degrees approximately here. And then we're going to draw in the angle. And I guess I'm going to do that in black to begin with. So here's the angle of 210 degrees. And then the reference angle, will be in blue, is 30 degrees. And as we know, the reference angle becomes important when we take the inverse trigonometric function, where it will always only give us the reference angle, which is the acute angle to each one of them. Okay, and then the second one is 150 degrees. So we're going to be roughly here. And the angle is 150 degrees. So there. And the reference angle is, again, 30 degrees. Next one is 143.4 degrees. So 143.4 degrees, just a bit less than 150 degrees, maybe approximately there. So the reference angle is this one, and that was the original angle of 143 degrees, and this one is the reference angle of 36.6 degrees. And one more exercise, 253.8 degrees, which is probably somewhere here. So the angle of 253 degrees is this one here, and the reference angle is this one. Okay, looks like I only had angles in the first and the second and the third quadrant. In the let me do a couple more here. 311.7 degrees, which ends up in the fourth quadrant. So 311.7, which is probably roughly here, almost shy of 45 degrees, or 315 degrees, and then we would have a reference angle. An angle of 311 degrees. I keep saying I'm sorry. Shouldn't do that so much, but just do it. And then the reference angle would be this one here, which comes out to 48.3 degrees. Okay. Let's go back to Word and fill those in. So the first one came out to 30 degrees, the reference angle 30 degrees, the reference angle 36.6 degrees. And this one came out to, let's see, I didn't actually name it earlier, 73.8 degrees. And then I actually did one more, which was 311.7, I believe. 7 degrees, and that came out to 48.3 degrees. Okay, let's go to the next exercise, which says determine the exact value of these. That one we can do in our heads. The reference angle to 120 degrees is 60 degrees. And now we have to see the reference angle is always in the first quadrant. That means when we take the sine, cosine, tangent, and so on of that reference angle, we always come up with a positive number. So we have to look at where is the original angle. 120 degrees is in the second quadrant, and it means that the sine is positive. So sine of 60 degrees, we know that we have that memorized, the square root of 3 over 2. Sine of 210 degrees. The reference angle of 210 degrees is 30 degrees. The 210 degrees is in the third quadrant, which means that the sine is negative. And of course, when I say that top of my head, that was required to memorize that the sine is positive in the first and second quadrant and negative in the third and fourth quadrant, and then also be memorized for cosine and tangent. Okay, sine of 30 degrees is 1/2, and then with that negative in the front. Tangent of 135 degrees. Reference angle is 45 degrees. 135 degrees is in the second quadrant, where the tangent is negative. Okay, tangent 45 degrees is 1, and put in the negative in front of it. 350 degrees, reference angle is 45 degrees. We're in the fourth quadrant, where again the tangent is negative. So again we come up with -1 for the answer. I'm double checking here with the answers in the book, and that is indeed correct. Okay, next example, next problem. Use a calculator for these. Cosine 238 degrees, secant 101.8 degrees. I put an approximation sign here behind here because I like to estimate them first. Cosine 238 degrees. Reference angle for that is 58 degrees, and the cosine of 58 degrees is really close to cosine of 60, which is 1/2, so I kind of expect to have 0.5. 238 degrees is in the third quadrant, where the cosine is negative, so I put negative in front of that. Okay, secant 101.8 degrees. Reference angle is 78.2 degrees. When I take the cosine of that, it's probably relatively small. I come out with 0.2, and as I said, I'm just estimating, maybe 0.2. I invert that, so because for the secant, 1 divided by 0.2 is roughly 5. Maybe that's what I come up with. Maybe it's going to be 6. Maybe it's going to be 10, but somewhere around there. I'm in the second quadrant, where the secant is negative. Cosecant 166.7 degrees. Reference angle is 13.3 degrees. Sine of 13.3 degrees is relatively small, so I'm just guessing, maybe 0.2 again. And then it's a cosecant, so 0.2 divided into 1 is going to be 5. And I'm in the first quadrant, where I'm in the second quadrant, but the sine and the cosecant in the second quadrant are positive nevertheless. Tangent 143.4 degrees. The reference angle is 36.6 degrees. I'm kind of in between 30 and 45 degrees for the reference angle, so between 0.577 and 1, so maybe make it 0.7. I'm in the second quadrant, where it will be negative. Okay, now I'm going to use the calculator. I have to admit I forgot to open the calculator actually earlier. Okay, let's go over here. And there it is. Clear this from the past recording. And let's see what we had. Cosine of 238 degrees. Enter minus 0.5299, respectively. Negative cosine of 58 degrees, the reference angle, which is the same. I'm going to note that down for myself so I won't forget. Minus 0.530, looks like 3 significant figures. Secant, which is 1 over, let's see, 1 over cosine of 101.8 degrees. There we go. Oh, I was pretty close in my estimate. And then the other one would be, let's see, we're again in the second quadrant, so put a negative in front of that, 1 over cosine of 78.2 degrees. And exactly the same one. Looks like 4 significant figures perhaps, so minus 4.890. Cosecant of 166.7, so 1 divided by sine 166.7. Again, I was relatively close, 4.347. 1 divided by sine of, let's see, 13.3 degrees. And there it is indeed. Tangent 143.4 degrees. My estimate, I believe, was 0.7. No? Yeah, negative 0.7, of course. Negative 0.7427. And negative tangent, the reference angle is 36.6 degrees. There we go. Okay, let's go back to Word. And plug in those answers. So this one was negative 0.530, negative 4.890, positive 4.347, and negative 0.7427. Okay, next problem set. Use a calculator for these here. Cosine of theta equals negative 0.7660 in quadrant 2. So we're taking the inverse of this one. So we're going to take the inverse of this one. When we take the inverse cosine of a negative number, you will see that we actually do end up in the second quadrant. So let's actually take this one out, so we truly come up with, as we plug it in on the calculator, that we truly come up with the first in the first quadrant with the reference angle. So on the calculator, we will do the inverse cosine of 0.7660. We're relatively close to 45 degrees. There's a little bit more than that, so let's just say 40 degrees. So reference angle will be 40 degrees, which we have to subtract from 180 degrees because we're in the second quadrant, so roughly 40 degrees. Then we virtually have the same problem, except we're in quadrant 3 now. Again, we have a reference angle of probably around 40 degrees. This time we have to add it to 120 degrees roughly. Then we have tangent equals 0.5890 in quadrant 3. We'll take the inverse tangent of that number. That's going to be a little bit more than the 0.5, in fact, hardly any more than the 0.577 degrees, sorry, not degrees, but 0.577 for 30 degrees when we take the tangent. So let's make it maybe 31 degrees. We're in quadrant 3. So we add it, so we come up with maybe 211 degrees. Then we're in quadrant 1 here, and well, we're simply going to come up with 31 degrees. Okay, let's go over to the graphing calculator. I'm going to jot these down here, my estimates, so I won't forget them. All right, graphing calculator. Okay, we're going to take the inverse cosine, inverse cosine of 0.7660. There, 40 degrees, pretty much exact. We are in the second quadrant, so we subtracted from 180. Yep, around at 140.0 for significant figures. Then we're in the third quadrant, so we add that number. Actually, let me do this here. Yeah, save entry. There we go. So we add that result to 180, 220.0. Then we had the tangent, the inverse tangent of 0.5890, 30.5 degrees. That's actually the answer to the last problem we had. And then for the other one, we're in quadrant 3, so we add the result, 210.5. Okay, go back to Word and plug in our answers. 24.0, I was right on. 220.0, I was right on in my estimate. 210.5 degrees, I consider that I was right on. And 30.5 degrees. When I say I was right on, well, we have memorized the approximate values here, so I can only do it usually to the nearest 5 degrees or 10 degrees of my estimates this time around, even to the nearest 1 degree. You can't really do any better in your head anyway. Okay, let's go to the next problem set. Find theta, and apparently we have given the exact values, so we should be able to do this in our heads. Cosine of theta equals negative square root of 3 over 2, which means the reference angle to that one would then come out to 30 degrees. So reference angle is 30 degrees. We're in quadrant 3, so we come up with 210 degrees. I just remembered that on the last problem set, I meant to go back and plug in the numbers and go backwards and check them here for a couple of these. So when I go back to graphing calculator in a couple of minutes, I will do these two problems here just to check that the tangent of 211 degrees is indeed this one, and the cosine of 220 degrees is indeed this one. I just remembered that. I want to go back. And then I do something similar here, like the first 2 or 3. I'm going to do the same thing. Sine theta equals negative square root of 3 over 2, so that will put us at a reference angle of 60 degrees. and we're in quadrant 4, so I subtract 60 degrees from 0 or from 360, and I come up with 300 degrees. So the first one here was 210, and then the next one is 300 degrees. And I'm double checking my answers here in the book, and I believe I am on the right track so far. Yep. Okay, this one here, actually in the meantime I do prefer to write this as square root of 2 over 2. So the reference angle is 45 degrees. I'm in the second quadrant, so it's 135 degrees. Let's see, square root of 3, so that's the reference angle will be 60 degrees. We are in quadrant 3, so plus 180 is 240 degrees. The reference angle to this one here is going to be 30 degrees. We're in quadrant 3, so we come up with 210 degrees. Secant theta equals -2. So when we take the reciprocal of that, we come up with -0.5. -0.5 for the cosine. The reference angle for that one is going to be 60 degrees. We're in quadrant 2, so we come up with 120 degrees. Okay, let's go to the graphing calculator and just double check these here. And I believe actually that was the last problems that we had. So let's just double check a few of these. Okay, whoops. Clear. Okay, what I wanted to double check was actually from the last problem set, cosine of 220 degrees going backwards gives us the original -0.766, and then tangent of 210.5 degrees gives us the original 0.5890. That was from the previous problem set. Here, taking the inverse cosine from this last problem set we just did of the square root of 3 over 2. So 30 degrees, and we were in quadrant 3, so the answer is the 210 degrees that we had. And again, checking that answer, cosine of 210 degrees is indeed the original negative square root of 3 over 2. And just one more, the inverse sine of the square root of 3 over 2. 60 degrees, we were in quadrant 4, so we come up with 300 degrees, and then we double check that sine of 300 degrees is the original negative square root of 3 over 2. And with that one, I conclude this problem section for the reference angle.